Alright guys, so let's get into this. We're going to do some more assembling of the chassis, and hopefully we'll get it to where we have wheels and gearboxes mostly on. This might be a little bit longer, but we'll see how it goes. So the first thing I'm going to do is, my screen recorder is a little weird and it only lets me record one window, and currently that's set to Inventor. So I just went ahead and downloaded the parts we're going to need from VexPro. It's pretty easy to search, just like any site. There's drop downs and everything, and you can get to the parts. I suggest exploring the website yourself, and then you can, if you scroll down, it'll have like a downloads or a CAD tab, and you can download whichever part you want. So I'm just going to place, you can see I downloaded 4 parts, it's a Versa hub, an aluminum one, the wheels I like to use, the 6-inch traction tire mounted on a 6-inch traction wheel, bearings, and pulleys. With these we should be able to do what we need to do today, as well as I have the gearbox we use this year that I'll import from my files to get in here. We're going to start with placing some bearings. Select that, open. Okay, this is just it importing the different file type. And we're going to need 1, 2, 3, 4, 5. Notice I didn't put one over this hole because that's where my gearbox is going to go. So the bearing is in the gearbox design, so I don't need it here. Remember, okay. This is the same assembly, so I don't need to worry about grounding anything. But I can start constraining these. So there are patterns you can do to constraining, but I like to just do them one by one. Also worth noting, the sound of constraining things gets really annoying really fast, so turn your sound off. Here, I'll explain what I just did there on the next one. You know, you're selecting your flange to the face that you're wanting it to be touching. That's normal, right? That's just like what we covered before. But then on a circle, I can select any round surface, so, and it's going to give me that center axis. You can see that green dotted line right there. I can't really move along it, but it's right there. And any of these cylindrical, the outside face of a cylinder, whatever you might call that, it's going to give you that center axis. So I can select that, and along with, number 2 is going to be this face right here. That's worth noting, actually. If you ever want to change what it is you're constraining, up here you can click and select your first face, and then it'll automatically send you to number 2 to select your second face to constrain, and apply. And just like that, that bearing's where I want it. Worth noting, these will be able to rotate in place, which is fine. If you remember the 3 constraint rule, that doesn't really apply to things that would rotate in normal life, right? Like a bearing would be rotating, so it's okay if it has that freedom to be able to rotate. Same thing with a wheel or a gear or anything that rotates on these robots. So I'm just gonna speedily do these. This is kind of repetitive. Feel free to skip forward. Yeah. One thing that's not important, this mouse I have is the 3D Connection wireless space mouse, and it does have a learning curve, but once you figure out how to use it efficiently, it is so helpful to not have to go up here to this thing anymore and like click and zoom and try and find parts. I can just fly around wherever I want to. That's pretty nice in my opinion. Alright, so let me double check. 3, 2, 3, 2. That looks pretty good. I can X out of that. Yeah. Now that we've done all that work, one thing we should have done before, but we didn't, is save this thing. You want to save your assemblies fairly often, because if for some reason your computer shuts down or Inventor closes or something happens, you want to have the latest version of your work and it doesn't autosave, so you need to make sure you click save so you don't lose hours of work. I spent 2 hours working on an assembly and then to find out my computer crashed or ran out of power or something and shut down and I lost it all and had to go back and redo it. It's very frustrating, so we're going to go ahead and save this. And I just saved that as chassis under the file. And yeah. So the next thing we're going to do is start building our wheels. And now I could assemble each one of the wheels in here with the pulleys and the hubs and everything. I don't do it that way. I do it like I would in real life, and I make that a separate assembly that I can assemble off-site, and then I import it into the chassis assembly, but just like you would a part to be able to do it. So let's do that. We're going to make a new assembly here, and we can place in, yeah, we're going to need a pulley. Before I move on, I'm going to go ahead and ground this because that's what you want to do. It doesn't really matter in this assembly which part is grounded, just as long as one of them is. I'm going to place, sorry, I clicked the wrong thing. I'm going to place Versa hub. I'm actually going to place 3 of these because that's what I've found works best for doing these, is if I have 3. Some of them in real life I would 3D print, that way we don't have to spend money on the aluminum ones, but that is okay for the sake of this video. And then I will place my wheel here. It'll load. One thing you'll learn about CAD is there's a lot of waiting involved. And you'll get up and going really fast and everything, and then you'll have to wait. So one thing that we're going to talk about real fast is this is an example file that they have. You can get the CAD files for everything and do it yourself, which might actually be better because you can see this is too big. We only want the 1-inch version. So we have a couple of options. We can either just go with it, which is what I'm going to do for this tutorial. That's not what you want to do. If it's your actual robot, unless you want the 2-inch wide configuration, then I mean, yeah, go with it because that's what you want. But I prefer the 1-inch wide configuration. It's a little slimmer, gives me a little less space taken up by my wheel well. So really, what I would do is I would download the file for the wheel and the file for the tire separately, and go ahead and do an assembly of that, and then import it into this rather than this example file. I just forgot that this example file was the 2-inch wide version, but now I'm just going to go with it. So first thing I'm going to do, throw this hub in here. Now this is where details kind of matter, right? Because I could leave this in here. It's going to get sandwiched in between a pulley. It doesn't really matter if it's aligned with the holes, but for the sake of, I don't know, me knowing it's aligned, I like to go ahead and constrain it for one of those holes. And then because that's what you would do in real life, right? You wouldn't just leave it. But yeah, small things, man. It's the small things. Get that all centered up, and you can see I like reached into that gap and did it. But you'll notice like on these, even the outside of these tires still gives you the center. It's really cool how that works. Waiting for it to load. Sorry. Do that, and then I can come back here and select yet again that hole, and now everything's all lined up. You can cap the outside of this guy with another one of these. And again, just getting it all centered. Tagged up like that. Looks good, and you notice when you align the holes, then your hex bore lines up for your hex shaft, and it all looks so much better. Even if you're the only one that's going to look at it, it's nice. And like I said, any round surface works really. You might want to double check that in your specific assembly, but any surface that's looks round and should be the centered there, it'll work. Anyway, now we have this done, right? And we have our pulley and everything all good to go. Hubs on. Like I said, in real life, this one and this one would be 3D printed, but it's essentially the same part. It doesn't really matter how it is in the assembly. It's kind of a placeholder, especially for the sake of this tutorial. It's just fine. So I'm gonna file, save as, wheel. Oh. There. Yep. Okay. Go ahead and let that load up. And we'll move back over to our chassis assembly. So for those of you who haven't noticed, this little toolbar down here is how we can move from the different things we have open. So I still have my rail and this open from tutorials 1 and 2, as well as the chassis assembly is open down here as well. So what we can do is we can notice when we place those files that weren't inventor files that we had downloaded, it changed this to place imported files. Now that's not what we want when we're placing something. You can even see, like, if I click it, I can't see the parts I've made. So to get around that, there's a little drop down, and you can switch it back to just place. And then now my imported files don't even show up. But if I wanted my imported files to show up here, what I like to do is come down to files of type, and I can click all files down here. And now all of the files that are in my folder show up. And you can notice it actually makes inventor file versions of like my different parts that I had downloaded. So you end up with some duplicate stuff, but I like to just leave it because sometimes deleting it breaks things, and it's not fun. Anyway, we're going to place our wheel 6 times, right? Because it's a 6-wheel chassis. Now that you can see this wheel in here, you can see how kind of insane the 2-inch wide is, but like I said, we're just going to leave it. Yeah. So currently we don't have shafts, but that's okay, because we don't know what length we need yet. So we're going to start out by doing this, and this isn't how it's going to stay, but I'm going to show you an issue with this. You can see there's no room for anything, right? If I have belts running here, and like there's just no room for error. So what I like to do is at least put an 1/8-inch spacer in between there. What I found is on chassis I like to use a 1/4-inch spacer. So let's make that little spacer real fast. It's nice and easy. Start 2D sketch here. A circle, 0.75, 3/4 of an inch. That's fine. And then in the rectangle drop down, there's the polygon feature, and it can make any size or any number of side polygon. So 6 would make a hexagon, just perfect, centered. Come out with it, and then we can dimension using this tool from here to here. And now 0.5 would give us our 1/2-inch hex, but we want a 3D print, so it needs to be oversized because 3D prints shrink. So we'll do 0.55. Ooh, I added an actual decimal in there. There. Finish sketch. Extrude here. 0.25 inches. Perfect. And then we can say file, save as, spacer. I probably should have labeled what size spacer that was. You'll learn that I'll regret that later. Like I said, I'm bad at naming things. Now though, I want to put the spacer here, but this wheel's stuck, so I have to come back over to this toolbar and delete that mate to where I can then pull this away. Perfect. So now we're going to place our spacers, and we will need 6 of them. Excuse me, I'm going to take a drink of water real fast. Let's place these spacers. Yet again, like the bearings, feel free to skip through. This video is going to get kind of long with all of the constraining I have to do. but I'm not going to edit any of it out, partly because I don't know how to edit, and partly because I think it's good for you to see how long it takes, and you shouldn't feel bad about how long it takes you to constrain things, especially when you're just starting out. And yeah, I could go a little bit faster and try and constrain expediently, but then you end up messing up and having to delete constraints, and I find that just gets frustrating and ends up taking longer. Besides, with the current state of things in the world, it's looking like I've got a little bit of time. Alright, so now we can come back in and constrain that to that. Uh-oh, real fast I see another issue. Do you see it? That now sticks out past that, which is an easy fix, right? Because we know that that's just one constraint. We don't have any of our holes for our gussets or anything in here, so we can just go back up to rail and see where we did 3 inches, and we can just up that to, I don't know, 3.75. That looks good and gives us good clearance. But it's important that we do the same thing to this rail over here. So we're going to have the same issue. And just double clicking on that allows you to change that dimension. And then we can just go through and add in our wheels. Pretty simple. It's a lot of, like, once you understand how to constrain one thing, it's pretty much the same thing. It's just, it comes into more mechanical knowledge of where things go and being able to come up with, oh, a spacer here would make things so much easier, and I don't want the outside face of this bearing grinding up against this, and so I put a spacer, so because this inside face of the bearing is going to turn, right, with the bearing. That's the whole idea. So you don't want something on the outside face, but you want something on the inside face, and so having a spacer here, whatever dimension it might be, is good. Worth noting, though, you don't want to use like a 1-inch spacer, because then you would have to bump this rail into like here, which isn't good. You want this to be as slim as possible. Yet again, why we use a smaller size wheel, and then, or a smaller width wheel, and then you don't want it that far out on the shaft, because then the leverage isn't in your favor, and the shaft is more likely to bend because it's longer. Yeah, with that rant over, I'm going to go back to constraining wheels. You'll notice, like, sometimes I'll end up looking at things in really weird angles rather than, like, dead on. That's just an efficiency thing, which is more efficient to look at it at a weird angle where I can see what I need to do still, or to try and move it to be, like, the perfect centered line of sight. It's more efficient to not have to move it as much, right? Alright, so, cool. Now we have the wheels on here, and I'm going to go ahead and, in this video, some notes. You can see they're on, they can spin. One thing you can do instead of constraints that I actually haven't even looked into all that much is use a joint, which is probably more of the proper way to do it, because ultimately this is a rotational joint, not so much a constraint. But constraints are the fast way to be able to get things into the computer. Joints are the way to make them pretty and make it to where you can animate them. But I've found constraints to be just fine for me in everything I've done. In the next video, we'll throw some gearboxes and shafts on and see if we can't get this thing what would be considered operational. Yeah, see you in the next video.